Alright then. So I think these were the examples which I had given you for reference yesterday. So let us discuss about these examples once, and we shall carry on. With the previous case, it was just with addition and multiplication, and it was a basic program which we saw. So today we'll be looking into one case where I have the particular input as 3 plus 4 star 5 plus 6 whole of n, and the other case is this will be looking into the next. Then so the first thing is we need to define the definition, right? So with the same production, the same semantic rule which we applied as specified in the previous one. So production L is tending to E and E plus T, T star F, F within brackets E and digit. So the semantic rules are the same with the values which are added to them. L dot val is equal to E dot val. E dot val is tending to E dot val plus T dot val. E dot val tending equal to T dot val. T dot val equal to T dot val star F dot val. T dot val equal to F dot val. F dot val equal to E dot val. F dot val is equals to digit dot lex value. The same semantic rule, but the differences happen with respect to the annotated pass-through. So here within this case, so what was my input? First thing is get with respect to the input. What was the input? So the input was 3 plus 4 into 5 plus 6 within the brackets, right? So let me write it out somewhere here. So 3, 4, 5, 6. So with this case here, it was 3. So 3 plus 4 multiplied by 5 plus 6 n, right? So this was our value here, and anyhow, as we all know, where does our production start from? Production is starting from the starting production, which is L. L is giving me E followed by n. So what is E? With the case here, E is giving me E plus T, but I have to look with the term here where I have star in the middle, right? So 3 plus 4 star 5 plus 6. So I need to start with the production of E plus T, because that's the production, or I can go from E plus T, or instead of E to T, T is T star F, make this T as one E, make this F as another E. That's also possible, two ways here. So let's start with L is tending to E and N. So E is giving me case of T, and T is having the chain of T star F, and again I have to get the plus value towards the left hand side. So T is made as F, F is to E, and E is E plus T, right? So E is giving me E plus T, E plus T. Of course, T is again F, and F is digit, right? So this diagram is gonna become a very huge one. So this is digit. Okay. So this ultimately E to T, T to F, and T F to digit. So I'm just writing this digit. Why? Because it goes to the next page and its visibility goes off. So here E is to E to T, T to F, and F to digit. So ultimately, what does this F make here? So the same thing, F is giving me to E. So because digit plus digit, and one more thing is within braces, right? So I have braces here, close and open and close, because f is giving me within braces e production. Okay, so again I have f is with respect to open bracket, e close bracket. E is giving me the same e plus t, so e production will be made as e and plus and t. So ultimately e is giving me with the value of t to f, and f to digit, and plus t to f, and f is giving me with the value of digit. And yeah, this is how the case of the program looks like, x, which has been just taken off. This is just a parse tree. When do we make it as annotated parse tree? It becomes annotated parse tree when we have the case of few values which are put inside it, so that makes the value. So what needs to be put into the parse tree to make it as annotated parse tree? It's all about the attributes, right? So attributes here is the val. So I need to push few values with respect to the digit. So which are the value? So 3 plus 7 and 5 plus 6. So 3, 4, 5, 6 are the values which I'll be sending towards the values here. So 3 will be pushed with this digit here, 4 with this digit, 5 with this digit, and 6 with this digit. So bottom to up is what the approach which we follow. So 3 here, e becomes 3, and here this t becomes 4. So 3 plus 4, 7 is the value which e gets here. So this f is 7, so this t is 7. Ultimately it should wait for some time because it has to get the value of the other side. So here 5, so 5 here, 5 here, so this e will be having 5, 5 plus this t will be getting the value of 6. So 5 plus 6 is 11. So 11 into 7 is 77. So this t value will be 77. Of course e is gonna get 77. Ultimately the value which reaches L is 77 n value. Alright, so basically it's a number, so 77 itself will be the value. So this is pretty simple, this is very easy. But the other thing is about the dependency graph. So how do we deal with the dependency graph? It's a directed graph where exactly the values move from the bottom to the top. Basically it's the same value how exactly you gave, right? We just put on some values over there, how exactly it moved towards the top end. So basically if you assign few values, right, from the lexical value towards the top, right, you go in a flow, right? That flow is gonna give you the dependency graph. Basically we start with the case of 3 here. We gave the 3 value, then this is my first step, from step 1 towards the topmost step of 2 here with the f value 3, and here it's 4. So similarly 5, 6, 7, right? So ultimately I gave with the value of, I added with the value of 4 and 7, which was my value e here, right? Ultimately it moved, and this was 8, this was 9, and this was 10. So I need to get the value from the other side also. So 11, 12, 13, 14, 15, 16, 17, both becomes 18, 19. These both will become 1. So it's my 20, 21, and 22. Do we have any cycles? Do we have any cycles? No. So this will be my topological order. So that's about the value which we sent. And the second example is 1 into 2 into 3 into 4 plus 5 of n. So here I need to start from the production of L. Yeah, basically it's all about the calculator input string. So in your exam you can expect these sort of values for the same production. What I suggest you people is get to know with the productions, right? This, if you can recollect this, so it's gonna be ultimately a very easy process to deal or to get the value of, I mean, to get the marks of around 6 to 7. It's easy to get the value, I mean, get the marks, right? So only thing is they give the production and they ask you for give the directed graph, right? So give the directed graph, and one thing is you start with the production, go with the semantic rule, and go with the annotated parse tree. Parse tree, annotated parse tree, both are same, but in annotated parse tree we have a attribute. So the case which we saw here, so here looking into the generated parse tree, 1 into 2 into 3 into 4 plus 5. So where do I start from? That's the case. So I have a production, E is tending to E plus T. You can go with this case, or you can also go with E tending to E T star F. So where T to E, again E with E plus T. You can go with multiple cases. So here, so L is giving me to E to T, and initially I go with T star F. So again, to T star F is giving me with T value. So T is T star F, again T star F, T star F, right? So 1 into 2, 1 is the value here, lexical val. So 1 into 2 into 3 into, so 4, 1 is I have within the brackets, right? So fourth is within the bracket, so it should have E production. So I have E here, so within the brackets. So 4, so 4 plus 5 and close brackets, right? So here it was the open brackets and here it was the close brackets. I think people can follow through the thing easily with the annotated with the value or the attributed here. So lexical value is getting the value 1. So 1 into 2. So it goes on. So here I have 1 into 2. Right? So so here I have 1. Sorry, color just messes. Okay, just change is fine. So I have 1. Here I have the value 1 here. So I get the value 2. So 2 into 1 is 2. So 2 again with into 3. Right, so 2 into 3 is 6, right? So this is 1 into 2 into 3, I got 6 values. So but the other hand I have 4 plus 5. So as it is in the brackets, according to the precedence rule, we go with 4 plus 5. 4 plus 5 is 9. Ultimately 9 into 6 is 54, and ultimately the value 54 will be sent on top, right? So this is about the annotated graph, annotated parse tree. The next thing is how to generate the important stuff, which is dependency graph. So dependency graph, however you move from the left hand side towards the other hands, just note with the terms of which way you are actually getting through with the value. So that will give you the dependency graph. So topological order, of course I started with the case here. Even though you mess up with the numbers here, you can give 1, 2, 3, 4, 5, but still it should be automatically rerouted with respect to the same value. All right. This is one other example where annotated parse tree goes in this way. Only thing is, what do I have? 9 plus 8 into 7 plus 6 plus 5. So what, 2 brackets, remember. So 2 brackets into 4n. So you have to go with the production of T star F in the beginning, right? So T star F is the production which you use from T star F. This completely will be T and this star F. So this F is again E, and ultimately E moves on to digit. Alright, so here again this is T, so T to F. So if this is T, T to F, F to E, so this complete term again will be made as an E. So E here within the values which I have, right? So within inside, what do I do is I go with again the middle term of E plus T, right? So again one after the other we need to solve. So a bit a small much more complicated program here. What do we do is, as I said, L to E, E to T, T star F is what we start, and from T star F, F again is giving me the value of 4, right? Ultimately this is about, we already solved this. on the other side. So here T is made as T star F. T is again with the F. This is the 1 because this was the outer bracket. It was the outer bracket. So within the outer bracket again I have few inner bracket values also, right? So E value, so let me write down what is it, 9 plus 8 into 7 plus 6. So 9 into 8, 9 into 8, sorry, 9 plus 8, 9 plus 8 into, within bracket, 7 plus 6. So 7 plus 6, then plus 5, then close that with into 4n. So into 4, oh sorry, this is into 4n. So this is solved out with this term here, right? So 4n easily solved out with this case. But the remaining outer is what? This is about the outer brackets which I told you. This is about the inner bracket here. So within the outer bracket, what do we have? 9 plus 8 into. So here this made it as one term. This is one term into. So that is why you see here E is giving you with, sorry, E is with E plus T, right? So this is a plus value here which you're gonna see, and on the other side we have 5 because this complete term and this complete term. So this is E plus 5. So okay, yeah, Inakshi, you can tell me what was the doubt here?